Okay, this is Unit 4, Lesson 5, Exploration 3 and 4, and this is talking about, we're starting talking about what influences climate. And this first question just asks you to talk about what today's weather was like, and what do you think caused the weather today, and how do you think that affects climate? So this is kind of an opinion and maybe be different because I am doing this ahead of time. But I'm saying it's sunny and warm, and I think that's just because the ocean currents maybe probably warmed up, and where we live, that's where a lot of the wind is from, coming towards the ocean. This paragraph talks about latitude and kind of goes back to the how the sun, right, the sunlight coming from directly or being more spread out when it's coming towards the top can affect wind, and it kind of goes back to those wind belts that we've talked about before and how the wind rises and cools, and you can see how like near the equator it's a really warm air rising, and then it cools down up in this area as the wind spreads out, right? And you can kind of see some patterns where near the equator the warm air is rising, and then it cools down and sinks, and then it kind of goes across the land, and then it rises again. But then by the time it gets to the poles, it's pretty cold because there's not as much sunlight coming. Sinks again because it's cooler. You got that type of action going on. I think the big takeaway from this lesson is, if this is confusing, is more this prevailing winds concept. Now, prevailing winds, right, we've read about this before, but as global patterns of wind that move in a certain direction. So prevailing winds a lot of times affects our weather, particularly, especially us in California, because we live right along the coast. So I think it's a little bit easier for us to see in real life because we have probably all firsthand experienced it. And this question talks about the average annual temperature in El Centro, which is over here, Centro, is 15 to 31 degrees Celsius. In San Diego, it's 14 to 21 degrees Celsius. So if you compare these temperatures, right, the difference in El Centro is about 16 degrees. The difference in San Diego is about 7 degrees Celsius. What that means is that the temperature in San Diego is only going up or down about 7 on average versus 16. And so why is that? So this is saying the more moderate temperatures in San Diego, moderate means it's not changing as much. San Diego has more moderate temperatures, is due to its nearness to the Pacific Ocean. And that's because, and it kind of goes into that more down here with ocean currents, but the thing to think about is that the ocean currents, right, a lot of the ocean currents, this ocean current is affecting the temperature of the wind right off the air right off of the coast. Because San Diego is so close to the coast, it's on the coast literally. The ocean really doesn't change its temperature very much, and because of that, it keeps the air temperature around it more balanced, and so that'll keep the air temperature around San Diego more balanced versus El Centro, where by the time the wind goes all the way across the land, there's more things affecting it, heating it up, cooling it down, things like that. We see that versus just us and San Francisco. If you go to San Francisco or the Bay Area, a lot of times it's pretty, it's not as hot as here, or it's not as cold as it is here usually. And that's because, again, it's closer to the ocean. The farther away you get from the ocean, you get more temperature extremes because you don't really have the ocean currents, and the temperatures help keep the air in a more balance. So cool, moist air masses form over the Pacific Ocean, where there is the California current. That's this one right here. And how might this process affect San Diego's climate? And this is just what I talked about. The current is changing the air temperature. It's keeping San Diego more balanced. Land forms and elevation. Now this goes back over to the rain, kind of similar to rain shadow effects, where it's talking about this prevailing wind direction. This is kind of cool because we can see this diagram right here is literally showing us this right here is supposed to be Lake Tahoe, and this is supposed to be the Bay Area right here. And so we are in the middle, which is kind of neat to think about. It's like, and this says, imagine we're walking from the coast to Nevada, and what would that be like? So I wrote it here, but basically, if you started here, the air is going to have a lot of moisture in it because it's coming off of the ocean. It's going to be, maybe just mild temperatures. So then as you go up into the coast range, it's going to cool down. You're going higher up in elevation. This talks about up here how elevation or how far away from sea level you are. So the higher you get, the more elevation you're at. So see, like it says, Yosemite has glacial ice at its highest elevations around 13,000 feet. And you can see how, like, if you drew a straight line, here's the sea level, and the mountains are going above sea level, and the valley's pretty much at sea level. And as you go to Sierra Nevada, it's much higher above sea level. So as you go up, the air will cool down, and it will also lose some of its moisture into the mountains because it will condense to being water vapor, and it's the whole rain shadow effect all over again. And so then it gets to the Central Valley, and it will cool down a little bit as it gets into the valley. But the air is going to be more dry here than it was just over the ocean because we lost some moisture. Then this air is going to rise up over the Sierra Nevada mountains, and so the air would be a lot colder. It would be probably a lot more wet. And then as you cross over the Sierra Nevada mountains into Nevada or the Great Basin, the air is going to become much warmer, and it's going to become much drier because it's essentially going to lose all of the moisture in the mountains. That's the major rain shadow effect. Here's the rain, and here's the shadow of it. It's all dry. What factors influence the climates of Yosemite and Joshua Tree? So, well, Joshua Tree is in a basin, and it's in Southern California. It's in a more arid basin type, and Yosemite is it's more south, but it's like in this type of area on the Sierra Nevada mountains. It's on the western side a little bit, and so it's right in the mountains, high elevations. It's going to be wet, it's going to be rainy, it's going to have lots of moisture in the air. And then Joshua Tree is in the type of Great Basin area where it's on the other side of mountains, so it's lost all the moisture. And this takes a while, so I'll just kind of skim over it, and your numbers might be a little bit different here because what you're doing is the tick mark, this is like tick mark 1 and tick mark 2 and tick mark 3, and you're using the colors on it. Right, so tick mark 1 is like yellow, so that's between 40 and 60, so I said 50 inches precipitation. And then the light greens, this was between 15 and 25, so I put 20 degrees as I went along. Then the elevation, you're doing the same thing. You're just trying to match the tick marks with what color it is and write it down, and then you graph it. And it's hard to see on my graph, but you had a whole bunch of tick marks down here where it was the same elevation and everything. And so what I said was, one correlation is that a lot of the higher elevations have higher precipitation amounts. And when it's lower in elevation, it tended to have like these elevations that are 75, those are the lowest. Those have some of the lowest regularly recorded precipitation. The weird thing about this graph is that kind of makes it hard to see some of these things is that because the graph actually goes on the other side of the Sierra Nevada mountain range over here, there are a lot of areas where it's still high elevations, but there's not as much rain because it kind of crossed over the highest area right in the middle, and then you enter the rain shadow effect over here, these last two. So there's less rain in these last two than there are on the western side of the mountains. Those are some things I noticed right here. And then finally, using regional climate models. And there's actually lots of different ways to divide the Earth into 3 major climate types. But the first thing I thought was the equator and the poles, and then the stuff between the equator and the poles. Because the equator is getting a lot of sunlight all year round. The poles are getting not very much sunlight. And then these middle areas are kind of getting a balance between the two. And you would think like the North Pole and the South Pole, they seem to have very similar climates. And if you're in the near the equator in any of these countries, the weather is typically very warm, hot, and then when you think about these regions of the world, they also have similar weather patterns. We skipped this, and then there's this giant. This would be way easier to see if you have your books. There's this big old chart. And it says what regional climate types are found in the 2 national parks. And so you could use this up here and try and figure that out. But it's easier to look down below because it actually has them labeled, because this is on the same page in the book, in the physical book. And it shows, you can see Yosemite is right over here. And Joshua Tree is over here. So Joshua Tree is mostly this arid, but a little bit of semi-arid, and Yosemite is mostly Mediterranean and the humid continental. Much of California you can see is Mediterranean, and Mediterranean is, if I go up, Mediterranean is in this area of Europe, and why the reason that they call it Mediterranean climates is because these middle areas are a lot of times described as having a Mediterranean climate because, well, first of all, many people lived in the Mediterranean area before we found out that people lived over here too. And so it's kind of like just stuck as the description of the weather patterns that are around the 30-degree north latitude. So a lot of the United States, even down in some parts of South America and over in the actual Mediterranean area. So that's where that name comes from. And then this says that Eureka and Alturas have different regional climates, even though they are at the same latitude. Part of this reason is their nearness to, so I said they have different, so Eureka and Alturas are up here. Eureka is over here, Alturas is over here. They have different regional climates, meaning their climate in the two, like this is the humid continental climate and this is a Mediterranean climate. It says part of the, even though they're at the same latitude, part of this is their nearness. Oh, I totally misread this. Part of this is their nearness to the, I said the equator, nearness to the ocean. So why, I answered this flip-flopped. So why do these have different, I was reading it thinking that they were the same or similar climates. The reason that they have different regional climates, even though they're the same latitude, because they're about they're both a little bit north of 40 degrees latitude from the equator, it's because Eureka is on the coast and Alturas is inland. Truckee and Fresno also have different climates that are mainly due to what? So Truckee and Fresno, Truckee's up here, Fresno is down here. And I also said their nearness to the Pacific Ocean because I know that, I think you could also say their latitudes because they're, obviously their albedos is how much light they're absorbing, which, they're the whole cities, so that's hard to measure. Their nearness to that shouldn't really matter, but their latitudes, I think, could have an effect because you can see how Fresno is about maybe 37 degrees north. Truckee is closer to 40 degrees north. But I would say more, it's probably the ocean, because when you have the ocean, at Fresno, the air from the ocean is going over that first mountain range, and then it's getting to Fresno, whereas the air from Truckee is going over this first mountain range, then into the valley, then it's going back up into the mountains. Truckee is up right by Tahoe. So I said their nearness to the ocean. And that is it for these.